Hello everyone, I am Dr. Atasi, Assistant Professor in MLR. Today I will discuss about semiconductors. So here I will go through introduction to semiconductors, then classification of semiconductors, which is classified into intrinsic semiconductors and extrinsic semiconductors. So let's go into details. So first, why we are using semiconductors? So mostly we know that the conductivity of conductors are very good. So why we are not considering about conductors and why we are using semiconductors in most of the devices? So the answer to this is, if we are adding any impurity to any conductors, that time what will happen? The conductivity will be decreased for conductors. And also if the temperature we will increase for conductors, that also will be affecting the conductivity. But in case of semiconductors, increasing temperature and addition of the impurity, we can rectify the conductivity of the semiconductor. That means it will be, the conductivity will be increased. That's why mostly we are using semiconductors in all the semiconductor devices like PN junction, LED, solar cell, PIN photodiode. There we are using all the semiconductors. Now, what is semiconductors and what are the basic properties? So semiconductors, the conductivity will be lying between conductors and insulators. Then we can classify these semiconductors based on the resistivity also. So we know that resistivity of the conductors will be lying between 10 to the power minus 8 ohm centimeter to 10 to the power minus 4 ohm centimeter. And for insulator, the resistivity is 10 to the power 8 ohm centimeter to 10 to the power 18 ohm centimeter. So we can clearly see here the resistivity of this semiconductor will be lying between the resistivity of semiconductors and insulator, which is 10 to the power minus 8 ohm centimeter to 10 to the power minus 4 ohm centimeter. Again, we can classify this in the basis of band gap. So band gap is nothing but the distance between the valence band and the conduction band. So here the band gap of semiconductor will be lying between 0.2 to 2.5 electron volts, and all the semiconductors have negative temperature coefficient. So these are the basic points of semiconductors, how we can classify semiconductors. Now we will go to classification of semiconductors, means what is the categories of semiconductors that we know. So mostly all the semiconductors will be classified into two types. One is intrinsic semiconductor and another is extrinsic semiconductor. Now we will go into details what is intrinsic semiconductor and what is extrinsic semiconductor. So intrinsic semiconductor is nothing but pure form of the semiconductor. So these are the natural or pure form of semiconductor. Mostly here the conductivity will be due to the thermally generated charge carriers. So here the few examples are silicon, germanium and gallium arsenide, indium antimonide, cadmium sulfide. So these are the examples for our intrinsic semiconductors. So in this you can say normal elements of the periodic table, silicon and germanium. So these are known as elemental semiconductors. And here you can say, see, there are some compounds which we are considering as intrinsic semiconductors. So these are known as compound semiconductors. So here let us consider about silicon. What is the atomic number of silicon? 14. So silicon is having atomic number 14. So there will be 14 electrons in silicon. So if we will see the electronic configuration, this is neon, which is atomic number 10, and after that we are taking 3s2 3p2. We can see the electronic configuration. We are having 14 electrons in silicon. Here these 14 electrons will be distributed as 1s2, 2s2, 2p6, 3s2 and 3p2. This is the electronic configuration for silicon. So we can see outermost orbit, that is the third orbit, it is containing 4 electrons. So here we are having 4 electrons in the outermost orbit, and we know that in all the metals or semiconductors, the outermost electron, which are valence electron, as those are loosely bound to the nucleus, those will be participating in the conduction process. So, here these 4 electrons will be participating in the conduction process. So, we will see how these 4 electrons can be arranged. So, here I am considering a silicon atom which is having 4 valence electrons. We can see there are 4 valence electrons. Likewise, we are considering a silicon crystal. So, there will be other silicon atoms surrounding it. So, all the silicon atom will be have those 4 valence electrons. So, we can see one silicon atom in the center, it is making a covalent bond with the other valence electron of the adjacent silicon atoms. So, likewise, we can see here 4 covalent bonds will be formed. So, here in silicon crystal we are getting 4 covalent bonds. So, here all the electrons will be bound in covalent bond. So, no free electrons here. Then how these charge carriers will be coming into picture. So, here we can see, as we have discussed before, no electrons is free to participate for conduction when at 0 Kelvin. That means when at absolute 0 temperature there is no free electrons for the conduction. As we will increase the temperature, that time what will happen, due to the increase in temperature, electrons will be acquiring sufficient amount of energy and that will break that covalent bond. We can see here this covalent bond will be broken and electrons will be going out. That is why we will get free electrons. In this way, electron hole pair will be generated. So, hole is nothing but absence of electrons. As one electron is being free, so there we are getting free electrons and holes also will be there. So, these electrons and holes will be acting as the charge carriers. Here, for intrinsic semiconductors, we will consider where the Fermi level will be lying. What is Fermi level? Fermi level is the outermost energy level where electrons will be there in absolute 0 temperature. So, where the Fermi level for intrinsic semiconductor, it is lying exactly in between conduction band and valence band. We can see from this figure. Next, we will go to extrinsic semiconductor. So, intrinsic semiconductor, I told that it is pure form of semiconductor. Extrinsic semiconductor is what? If we will add some impurity to any pure semiconductor, then we will get this extrinsic semiconductor. So, here extrinsic semiconductor can be again divided into 2 categories. One is p-type semiconductor and another is n-type semiconductor. So, first we will go in details for n-type semiconductor. N stands for negative. So, we can say that these are negative kind of semiconductor. Negative means what? We are considering the charge carriers, which are electrons. If electrons, the charge of electron is always negative. So, we can see easily, we can remember that here the majority charge carriers are electrons. So, how to get this? So, here we are adding some impurity to pure semiconductor. We can see which impurity we are going to add. So, silicon was having valency 4. We have already discussed before, silicon is having valency 4. If we are adding any pentavalent impurity to silicon, then we will get this n-type of semiconductor. So, these pentavalent impurities are nothing but the 15 group elements of the periodic table. You can go on revise for the periodic table, you can see the 15 group elements. So, like phosphorus, arsenic, antimony, these elements we can add with any pure semiconductor to get this n-type of semiconductor. We can see here we are taking phosphorus, which is whose atomic number is 15. So, adding phosphorus to silicon. Here phosphorus is having atomic number 15. So, what is the valency of phosphorus? The valency will be 5. So, electronic configuration is 1s2, 2s2, 2p6, 3s2 and 3p3. So, there are 5 electrons in the outermost orbit. So, 5 valence electrons are there. Now, we can see this phosphorus is having 5 electrons in its outermost orbit and we are adding this phosphorus to silicon. So, already discussed, silicon is having 4 electrons in its outermost orbit. So, these 4 electrons from the adjacent 4 silicon atoms will make covalent bond with 4 electrons of phosphorus, 4 valence electrons of phosphorus. Now, we can see 1 electron will be left out here from phosphorus atom. So, that extra electron will be acting as the charge carrier here. So, in this element we can get number of phosphorus atoms. So, number of electrons will be there. So, these free electrons will be acting as a charge carrier or majority charge carrier in N type of semiconductor. So, first point is N type of semiconductor, we are taking electrons as the majority charge carriers. So, few holes will be there. So, holes will be the minority charge carrier in this extrinsic semiconductor, which is N type. Then the energy level corresponding to loosely bound electrons lies in the band gap just below the conduction band. So, we know where will be the electron energy level of the outermost electron, that also we need to see. So, here N type semiconductor means we are having number of electrons more free electrons are there. That is why here the energy level or Fermi energy level will be close to the conduction band. In intrinsic semiconductor, it was just middle of the conduction band and valence band. Here this will be close to the conduction band, and we can see here the donor level, which is consisting of the free electrons. This is also near to the conduction band and just near to the Fermi energy level. So, next we will discuss about P type semiconductor. So, P type semiconductors means P stands for positive. So, something is positive here. That means what? The charge carriers will be positive here. So, here to get these positive charge carriers, which is known as holes, we will add trivalent impurities, which is having 3 valence electrons in it. So, mostly in the periodic table, if you will see the 13 group elements, which are like boron, aluminum, gallium, these are the elements which we are adding to get these P type semiconductors. So, here we can see, I am considering about aluminum. What is the atomic number of aluminum? 13. So, what will be the electronic configuration? 1s2, 2s2, 2p6, 3s2 and 3p1. So, we can see in the outermost cell how many electrons are there? 3 electrons. So, here there are 3 valence electrons to participate in the conductivity. So, we are adding here aluminum with silicon. So, silicon is having 4 valence electrons and we are adding it with aluminum. So, aluminum which is having 3 valence electron. So, now this aluminum will be forming 3 covalent bond with the adjacent 3 silicon atom. For the 4th silicon atom, we can see here there is the absence of electron to make the 4th covalent bond. So, we can say this absence of electron is presence of hole. Hole is nothing but the absence of electron, that is a deficiency of electron. Deficiency of electron. As we are having a deficiency of 1 electron, we are considering it as a hole. So, here there will be number of holes. If we are considering a number of aluminum adding to silicon, there we will get a number of holes, and these holes will be acting as the majority charge carriers for P type semiconductors, and here electrons will be the minority charge carriers, and we will consider about the energy level. So, here the acceptor energy level, here as we are having holes, hole is nothing but lack of electron. So, that will be the acceptors. So, those acceptor energy level will be lying close to the valence band. We can recap that for N type semiconductor, we are having donor level which was near to the conduction band. Here we are having the acceptor level which is close to the valence band. Okay. So, this is all about P type semiconductor, and we can these are few examples for P type semiconductors. Then summary. So, what we have learned today? So, we have classified semiconductors. We have classified semiconductors into how many categories? 2 categories. What are those? One is intrinsic semiconductor and extrinsic semiconductor. And then we have classified extrinsic semiconductor into another 2 categories, which is p-type semiconductor and n-type semiconductor. So, this intrinsic semiconductor is nothing but pure form of semiconductor. In extrinsic semiconductor, we are adding impurity. So, here we are adding impurity. By addition of impurity, we are getting extrinsic semiconductor. In p-type, which impurity we are adding? We are adding trivalent impurity. And in n-type, we are adding pentavalent impurity. And what is intrinsic semiconductor? These are mostly tetravalent elements. Like its valency will be 4. And what are the properties of p-type and n-type? As I discussed, here the majority charge carrier will be holes. Majority charge carrier will be holes and minority charge carrier will be electrons. For n-type semiconductor, the majority charge carrier will be electrons and minority charge carrier will be holes. So, this is all about the classification of semiconductors into intrinsic and extrinsic semiconductors. So, next class we will be discussing about the classification of intrinsic semiconductor, which is further we are dividing into direct band gap semiconductors and indirect band gap semiconductors. Thank you.